Hello HVAC geeks, gurus, and groupies. I'm starting the rough end installation phase of a new construction project. I thought I would try to document the process in a series of videos. This video will be some background on the design process and how it has changed over time. When I started down the HVAC road 20 years ago, I had a lot of questions that those I was working under didn't seem to have answers that satisfied me. Because one of the jobs that I was doing early on was laying out, fabricating, and hanging ductwork. I wanted to know how to properly size ductwork. I basically got two answers. The one that probably everyone has heard is that you set your ductulator at a 0.1 friction rate. They would often misspeak and say that you were setting your ductulator to a 0.1 static pressure. Well, these aren't the same things. Once I discovered recommended and maximum velocities, I quickly realized that this simple method was severely flawed. Once I discovered equivalent length, I found another glaring fault in this oversimplification. The second method was just as bad, if not worse. Always use 6-inch runs and 8x duct. You start at the end with an 8x8 trunk. You pull three 6-inch runs off of it. Then you increase the trunk 2 inches, and then you can pull another 3 6-inch runs thereafter. The truth is, correct duct design depends on many variables, but primarily starts off with a room-by-room load calculation. And that brings me to the second question I had that wasn't answered to my satisfaction. That question was, how do you size equipment? Well, one answer I got was that you take the volume of the building, square footage times the ceiling height, times 3 for a tight building, times 4 for an average building, times 5 for a very loose building. This gives you the heating BTU. Then you divide that by 60 to find the cooling CFM, of course 400 CFM per ton, so you can figure it out from there. But this has many faults, because it doesn't address any feature of the structure other than its volume. This might be simply intuitive, but it is wrong. We're not conditioning the volume of the building. We're conditioning the shell of the building, the exterior surfaces, because that is where the heat gain and loss is occurring. This is why I decided to purchase load calculation software very soon after starting my own business. I also took a much greater interest in correct system design, installation, and commissioning. I've said it before, but the ACCA is the best resource for manuals, guides, and continuing education. If you have any silly rules of thumb, please list them in the comment section for all our enjoyment. Yeah, alright, let's have a quick look at my library, because I consider this set of tools as important as any physical tools in my truck. Got equipment manuals at the top provided from manufacturers, along with the NATE reference guide. And down here I've got my ACCA manuals. I've got a Manual J. Just look at that guy, and let me tell you, it's nasty. That thing's gnarly. We've got the old Manual D. I carry one of these in my truck as well. Got new Manual D. Hart and Cooley registers and grills. It's got your velocity, stats, and throw and spread. That can be useful. And air distribution basics, basically telling you about air diffusion into spaces. Manual S is equipment selection. Manual RS, it's just a general overview of the whole ACCA system. This is a new one. This is Manual B, balancing and testing, and I haven't really got a chance to look at that. I've always kind of ad-libbed at balancing and had some success with it. But Manual H for heat pumps. Got a course I took, the 98% York modulating furnace. Geothermal training certificate program. Work on geos. I actually haven't read this book yet. That's kind of new. Psychometrics, if you don't know, that's a study of air and water vapor, humidity. And then this one's new. This is spas and pools, and at the beginning of this book it tells you that you must have mastered every discipline before attempting any of this. And read through this book, and they mean it. It's highly technical. I'd have to quit my job to wrap my head around that. So until I get a job with an auditorium in it, I probably won't devote much time to reading that anymore. But manual in, commercial load calculations. I've got quite a few here, but I'm gonna come over here, and these are manuals that I've made off of downloading off the internet. It's just equipment. It's got coil air handlers. I've got my AC and heat pumps, some York stuff. I got Goodman there. Because they don't supply those to you anymore, you've got to print them out yourself if you want them. And then, well, when a job starts, you get a set of prints, and this. I'm going to start talking about this project I did. That's probably the most difficult project that I've done as far as design work. This house was real unique. It was built out of 12-inch thick SIP panels, or structural insulated panels, and then it had a concrete slab that was floating on 10 inches of reclaimed high-density foam board. There's so many details to this house that I could make hours of videos about it. The 1 watt house videos I uploaded are of this house. This house required an energy recovery ventilator because it was so tight. Actually, the energy rater said that it was actually tighter than his equipment could measure, so his blower door test wasn't able to actually determine just how tight this house was. It was the tightest house he'd ever seen. So it's this house also, sorry, there was an energy engineer involved in the design of this house initially, and I had to work with him. He made recommendations on what equipment we'd use, and he changed his mind several times, but not until I generated designs for each. And I drew hand drawings, different portions of the system. Sorry if you're casting shadows on it, you probably can't see that well. This is how I used to do the logistical planning on these jobs with blueprints. I can scale the prints on my desk, which is also a light table. During this process, though, I changed from drawing designs on paper to using computer-aided modeling software. Fortunately, the owner of the house is an interior designer and was versed in modeling software. He had already generated the house in Google SketchUp,